Okay, so we're going to use our performance charts to determine the fuel that we're going to use for our climb and also the fuel that we're going to use for the descent, and then we'll use the E6B to determine our fuel burn during cruise. So to determine our fuel during the climb, we can look at the time, fuel, and distance to climb chart in the Piper Archer POH in section 5. There are a couple traps that are associated with this chart, so we got to be careful to make sure that we're using the chart correctly. The first thing that we should probably determine is our pressure altitude. So if I take a look at the weather for the current weather to determine our current temperature, then we should be able to determine the pressure altitude, the temperature, and the pressure. So at our departure airport of Brainerd, the current temperature is 5 degrees Celsius with a pressure of 29.90 inches of mercury. So hopefully you recall that to determine your pressure altitude, you just need to take your current pressure or current altimeter setting and subtract that from 29.92. You'll times that value by 1,000 and add that to the field elevation to determine your pressure altitude. So with a altimeter setting of 29.90, we can do some basic math. 29.92 minus 29.90, that leaves us with 0.02, times that by 1,000, and that equals 20. Now for our field elevation, if we take a look at the sectional chart, we can actually determine the field elevation of Brainerd. Right here where it says 1232, that is your field elevation. This 71 here, that is the length of the longest runway in thousands of feet, so it's 71. In hundreds of feet, so it's 7,100 feet. So 1232 is your field elevation. So we will add that to the value of 20 that we calculated here. So our pressure altitude today is 1252. So we can go ahead and transfer that information onto our navigation log. So our pressure altitude at departure, we said, was 1252 feet. So we've got that performance section all filled out now. So back to our time, fuel, and distance to climb chart. We said the temperature was 5 degrees and the pressure altitude is 1252 at the surface. So we're going to come up with two sets of values using this chart. We're going to find the values at the surface first. So 5 degrees is right here on the chart. I'll zoom in a little bit closer so you can see hopefully a little bit better. There we go. And then our pressure altitude of 1,232. So this line here is 1,000 feet. And then the line above that is 2,000 feet. So 1232 or 1252, excuse me, for our pressure altitude. 1252 is probably right about there. And now we're going to go straight across. And when you hit the first line here, so this first curve represents time, then you're going to go straight down. It looks like I would say that's probably maybe 1 or 2 minutes. So you can go ahead and why don't we call it 2 minutes? And then we're going to continue across until we get to the next line, which is right here. Go straight down for fuel. That looks to be about 2 gallons. We'll come to the next line, next curved line there. Go straight down again. And that looks to be probably also about 1 to 2 miles. We'll call it 2 miles there. I don't know if you saw that line. There we go. Okay, so we got our values at the surface. So 2 minutes, 2 gallons, and 2 miles. Now, that assumes that we're going to climb from the surface to the surface, which of course is not true. So we have to also find the values of the cruise altitude of 4,500 feet. If you remember back, we determined that the temperature at 4,500 feet was -1 degree, So if we assume that the pressure altitude is fairly similar, so at the surface we added 20 feet to the elevation to get the new pressure altitude. So if we add 20 feet to our cruise altitude, that should be pretty close. So at 4,500, the pressure altitude up there is probably about 4,520 feet. So it's not that different really. So if we look for -1, so -1, so this line here would be 0. This is -5, so -1 would just be right about there. And 4,520 is probably right about there. Okay, so now we're going to do the same thing. We're going to move along the chart here until we get to the first curve. For time, and if we go straight down, that looks to be about 6 minutes, I would say. We'll come across to the next curve. Stop right there. That looks to be about 3. And then we'll go back. Let's make sure I didn't lose my place here. There we go. Going across to the next curve. That looks to be about 10. So we got our two sets of values, and we subtract them. So we'll take the difference. So we got 6 minutes minus 2. So that equals 4 minutes. 3 minus 2, 1 gallon. And 10 minus 2 is 8 miles. So in our climb from pressure altitude of 1,252 up to our cruise pressure altitude of 4,520, then we are going to, that's going to take us 4 minutes. We're going to burn 1 gallon of fuel, and it will take us 8 miles horizontally to get up to that altitude. So in the bottom left corner of our navigation log, we can transfer some of that information. So our climb, the time to climb, we said was 4 minutes. So I'm going to put that right there, 4.0. And then the fuel, we said we would burn 1 gallon. So we'll place that right next to that. And we also said that's going to take us 8 miles. We don't really have a box for that, so if you want to, I like to place that just off to the side here. 8 nautical miles for that climb. Now our taxi and takeoff fuel, if you read the notes on the chart, the note says that this chart includes fuel allowance for start, taxi, and takeoff. So that 1 gallon that we calculated with the chart, that includes the fuel that you will use to start the engine, taxi out to the runway, and depart. So that's not a lot of fuel, which is good news, to start, taxi, depart, and climb up to our cruise altitude. Now we have the row for cruise, which we'll use the E6B to determine, and then we're also going to look for descent, which we'll call this, instead of approach, we'll call that descent. Kind of the same idea. So luckily Piper gives us a chart for that. If we take a look here, try to find it in section 5. As you can imagine, it's called the time, fuel, and distance to descend chart. This chart works the same way as the time, fuel, and distance to climb chart. So again, our cruise pressure altitude, we said, was about 4,520. If you wanted to, we could actually make that a little more accurate and look at the weather in Grand Forks. So in Grand Forks, the altimeter is 29er, 89er, so that's really not that much different. So we can go ahead and I think stick with 4,520. And at 845 field elevation, that would probably be about 865 pressure altitude on the ground in Grand Forks today. The temperature on the ground there is 1 degree. So if we have 1 degree right here, looks like, yeah, right about there probably, and 865 pressure altitude is probably right about there. So then we'll move across the chart to our first curve, which is right here. If we go straight down, that gives us a time of about 3 minutes, I would say. If we come to the next curved line there, that looks to be about 0.5 gallons. And then the next line is right here, and that looks to be about 5 nautical miles. So now we'll look at our cruise pressure altitude of 4520. And again, we said temperature is -7 up there. So if you find -7 along the bottom, and we'll meet up with 4520, which we'll say is probably right about there, pretty close. So we'll move across the chart and come to our first line here. We'll go straight down. That looks to be about 12 minutes, I would say. Next line here looks to be about 2.5 gallons. Call that 2.5. Next line here looks like about 26 miles. So we'll call that 26. So again, we'll subtract out those values here. So that's 9 minutes. That would be 2 gallons. And then this would be 21 miles. So again, we'll take that information, transfer it to our navigation log for our trip fuel information. So for the descent, we said that that's going to take us 4 minutes. And we will burn, or excuse me, I'm sorry, I'm using the wrong chart here. 9 minutes. So there we go, there's the values that we just calculated. So we got 9 minutes and 2 gallons. And the distance, 21 nautical miles. Okay. Now for alternate, this is only a consideration for IFR aircraft, so that's not something that we're worried about. Reserve, we always, according to UND safety policies and procedures, need to carry a 45-minute reserve. So this time here will always be 45.0, so we'll use the E6B to calculate how much fuel that actually is. We'll also use the E6B to calculate our cruise fuel. Then we'll determine the total fuel that we need for the flight, and then the fuel that we'll have after we arrive at our destination. So starting with our cruise fuel, if we pull out our E6B once again, we said that our fuel burn rate was 9.5 gallons per hour. So using the E6B, we can calculate this. So we'll set our index to our fuel burn rate of 9.5. And now for cruise, we would like a total time. So really, the best way to do this is to add up all the times that we have calculated between each leg. So we've got 1.6 plus 2.6 plus 3.7 plus 7.3 plus 5.2 plus 5.8 plus 8.4 plus 5.8. We go to our other page. Plus 8.4 plus 9.8 plus 9.4 plus 6.3 plus 6.3 equals 80.6. If we divide that by 60, that gives us 1.3 hours. So it's up to you how you want to write that. If you just want to write that as minutes, you could just put 80.6 in there, which of course is 1.3 hours. Okay, so we've already got our E6B set up to our fuel burn rate. So if we look for 80.6, which is our time, that will be on the inner B scale. So 80.6 would be right about here, because this would be 81, right? So 80.6 right about there. So it looks like the total fuel that we need is about 12.8. Why don't we round it to 12.8 gallons? So 12.8 gallons are needed for cruise flight. Now, the way I plan across country, you'll notice that obviously at Brainerd we're not going to be at 4,500 feet. We're going to be in the climb. Same thing with our descent back into Grand Forks. We're not going to be at 4,500 feet. We're going to be in the descent. In my opinion, I just calculate using all those checkpoints, assuming that we're at those altitudes, all those checkpoints. That way it gives me a little bit of extra fuel, or at least makes the requirement a little bit higher. Now, if you wanted to be really precise, you could subtract those checkpoints out, and you would actually determine where you would be at the top of the climb based on the climb distance that you got from the chart, and that could be a checkpoint that you could put in there and be really precise. But that level of precision, I think, is not entirely necessary at this point. So this gives us a little bit extra buffer in the fuel that we're going to carry on board the airplane. So next thing is our reserve fuel of 45 minutes. To calculate reserve fuel, you want to use the cruise fuel burn rate of 9.5. 45 minutes, our time will be on the B scale, which we have right here. So that looks to be about 7.1 gallons. So we'll rate that there. So now we can add these things up, right? So 12.8 plus 7.1 plus 2 plus 1. We have to carry at a bare minimum 22.9 gallons of fuel on board the airplane for us to have a legal flight today. If you wanted to calculate the time as well, 45 plus 80.6 plus 9 plus 4 is 138.6. I'm going to convert that to hours. So that's about 2.3 hours of fuel we need to have on board at a minimum. Now, the fuel remaining, that's going to depend on how much fuel you have in the airplane at your point of departure. If we assume that there's full fuel on the airplane, that would be 48 gallons of usable fuel. So if we take 48 minus 22.9, that would leave us with 25.1 gallons remaining in the airplane. Again, 48 gallons of fuel at 9.5 gallons per hour. Well, let's look at the total fuel of 2.3 hours. So to determine with 48 gallons of usable fuel on the airplane at 9.5 gallons per hour, how much time would that give us? So we could look for the time on the B scale, which we said was, well, we don't know yet. We know that the total gallons is 48, so we'll look for that on the A scale. So 48 gallons, and that looks to be about 5 hours of fuel total. So that 5 hours minus 2.3 will leave us with 2.7 hours of endurance remaining on the aircraft once we land in Grand Forks. So we've got our fuel figured out. Pretty much everything else in the nav log is figured out. Now we need to add some additional information from the chart supplement in terms of our frequencies and airport information, and then we'll need to fill out the flight plan form as well.